Hi, welcome to Basic Math for today. We're going to be looking at multiplying and dividing with fractions. So, fractions are some of people's scariest things in math. I get more comments about how people hate fractions than really about anything else I teach in math. So we're going to try and make this as straightforward as we can. We're going to try and make it as, have as little bit of a scare factor as we can. This is a good place to start out. We're starting with multiplication and division because they're actually easier. Okay, some real basic steps, and then you'll be ready to multiply. Okay, so we're going to look at it first. I'm going to tell you what to do. Then we'll go and do a bunch of examples. We'll do examples with regular fractions, and then we'll also do some examples with mixed numbers. All right, so here we go. To multiply, you just go straight across. Really, multiplying fractions is just two multiplication problems instead of one. Okay, so you're going to multiply your numerators together, you're going to multiply your denominators together, and that will be it. That will be your answer. That's not so bad, but you do need to make sure that when you're done, if you can, you reduce your fraction. Division. First, we're going to flip our second fraction. So division's a little bit weird, but it works out really nice. Then we would just do a regular multiplication problem. So instead of it being division, we're going to end up multiplying. But you have to flip first, and flip the second fraction first, then we're going to multiply, and again, you're going to reduce. Notice, nowhere in any of these directions did I talk about getting a common denominator. Okay, that's for adding and subtracting. We do not need a common denominator to multiply and divide with fractions. So we're going to be looking at examples for all of this, and yeah, hopefully it'll be enough to get you going. All right, so let's do our first multiplication problem. Here we go. 3/4 times 2/5. So all I'm going to do is I just went straight across. 3 times 2 is 6. 4 times 5 is 20. So then I had the fraction 6 over 20, and I noticed that 6 and 20 are both divisible by 2. So I divided. 6 divided by 2 gave me 3, and 20 divided by 2 gave me 10. So my final answer here is 3/10. But I want us to notice something. Okay, you can do the multiplication this way and then reduce the problem when you're done. But if you notice it ahead of time, you can actually make your life just a little bit easier. So what I want you to notice is that back at the original problem, 2 and 4 are both divisible by 2. Notice that's what we ended up dividing by to reduce. Turns out you can reduce before you start. If you have any numerator and any denominator that are both divisible by the same thing, you can do it ahead of time. It makes your life just a little bit easier when you're done. So let's take a look. I did the exact same problem over here. 3 over 4 times 2/5. Now what you'll notice is that I kind of crossed out the 2 and the 4 because I noticed that they're both divisible by 2. So I divided 2 by 2 and I got a 1. I divided 4 by 2 and got a 2. And then you can see I rewrote the problem. 3 over 2 times now 1 over 5. And it gives me the exact same answer. So you're welcome to reduce after you multiply, or if you notice it, you can go ahead and reduce before you multiply. But if you do it before, just remember, any top, any bottom. They can be in the same fraction, they can be in fractions that are next to each other. If you have the unfortunate case where you have 5 fractions to multiply together, it could be the numerator of the first fraction and the denominator of the last one. It really doesn't matter. Any top, any bottom. If they are both divisible by the same thing, you can do the reducing. Let's do some more examples. All right, I have some more examples for us to look at with multiplying fractions. I suppose I should get some division ones up on the board next, maybe. All right, so I have 6 times 2/3. What do we do with the 6? Well, remember, it's 6 wholes. So the number of pieces in a whole here is just 1, right? Each whole is just 1 piece. So we can put anything over 1 and it doesn't change the number. 6 and 6 wholes is exactly the same. So I'm just going to rewrite it as 6 over 1. Now I have it times 2/3. This time I just multiplied and got 12 over 3. I noticed that they're both divisible by 3. 12 divided by 3 is just 4. You get 4 over 1, but that's just another name for 4. So remember, you can always switch back and forth between something over 1 and a whole number. It works just fine. They are exactly the same thing. For my second one, I have 9/7 times 14 over 3. This time I noticed there's a lot of reducing that I was able to do. I did two different things. First, I said, hey, 3 and 9 are both divisible by 3, so I divided them both by 3. You can see I put a 1 down here. 3 divided by 3 is 1. 9 divided by 3 was 3. But then also 7 and 14. There's nothing that says we can't reduce more than one thing. As long as it divides out evenly, you can do it. So 7 and 14 are both divisible by 7. 7 divided by 7 is 1. 14 divided by 7 is 2. And then we multiply. 3 times 2 is 6. 1 times 1 is 1. Oh, there's that number over 1, right? 6 over 1. And remember, that's just a whole number. It's just 6. All right, the last example I have here on this one is 3 over 8 times 7 over 9. This time the 3 and the 9 are both divisible by 3, so I do my division. 3 divided by 3 is 1. 9 divided by 3 is 3. For some reason, I decided to rewrite this one, so you can see I have 1 over 8 times 7 over 3 now, and I get 7 over 24. That's about it. Let's do some division, and then we'll do some mixed numbers, and we'll call this video good. All right, let's look at some division. Remember, same thing as multiplication. The only difference is you flip that second fraction first. That's it. So instead of having 2/3 divided by 3/4, I have 2/3 times 4/3, right? I take my second fraction. It's called a reciprocal, turning it upside down. So I turn it upside down, use the reciprocal, and now it's a multiplication problem. 2 times 4 is 8, 3 times 3 is 9. Nothing there reduces. Now, I want you to notice something. Back here at the beginning, those 3's are really tempting to reduce. Right? I've got a 3 on the top and a 3 on the bottom. The 2 and the 4 also, but especially those 3's because they're the same thing. You cannot reduce when it is a division problem. Okay? If you did that, if you just think about what would happen with just the 3's, right? They would both turn into 1's if you reduced it. Well, that would make both of these 1's, which would make my denominator now just 1. And 8 over 1 and 8 over 9 are not the same thing. So with division, you can't reduce it until after you flip. Okay, let me say that one more time. With division, you can't reduce until after you flip. Sorry, just can't. Doesn't work. All right, here's my other division example. Then we'll do a little bit with mixed numbers. 4/5 divided by 6. Now, keep in mind, any number can be written as a fraction if you just put it over 1. So I put my 6 over 1, and now I can flip it. I have 4/5 times 1 over 6. 4 times 1 is 4. 5 times 6 is 30. I don't know why I didn't reduce this one before I started, but oh well. 4 and 30 are both divisible by 2, and I get 2/15. Okay, so there we go. Let's look at the mixed numbers, and then we'll be done multiplying and dividing. Okay, last board that I'm going to give you for multiplying and dividing. Improper fractions. You can't multiply, not improper fractions, mixed numbers. You can't multiply or divide with mixed numbers. You just can't do it. I guess technically it's possible, but it's a real big pain. It involves some really goofy math, and just don't even try. It's probably not going to work for you. So instead, we need to make them into improper fractions first. So here's my example for it. 4.5 times 6 1/3. So you'll notice I made improper fractions here. I have 9 over 2 and 19 over 3. So if you need to, go back and watch the video on improper fractions. 2 times 4 is 8. 1 more makes 9 over 2. 3 times 6 is 18. 1 more makes 19 over 3. Now, I almost multiplied this one just straight across, and I got some pretty big numbers when I did that. Instead, I noticed, hey, look, 3 and 9 are both divisible by 3. So I divided them both by 3 first, just to make my life easier. 3 divided by 3 is 1. 9 divided by 3 is 3. Now when I multiply, I still get some kind of big numbers, but they're not as bad. 3 times 19 is 57. 2 times 1 is 2. It turns into the mixed number 28.5. And if you need to, here's how I got the mixed number. I just divided the 57 by 2. And when I did that, I got 28 with 1 left over. So the 28 wholes, and the 1 remainder goes over the denominator we started with. So there you go. That's multiplying and dividing. Good luck, and yeah, have a good day.